Back to my channel. In today's video, we're going to actually focus on a new standard. So we're now moving into standard 4.NF.4a, and this basically just means we're just going to be multiplying fractions using models and the associative property. So let's get right into it. We're going to be using the tape diagram strategy as well as the associative property. So remember, the associative property basically just means that I can arrange numbers any way I want to using multiplication. So for example, if I had 4 times 2 times 3, I know that I can multiply 4 times 2, which would give me 8, and then multiply that by 3 to get 24. But the associative property also tells me I can arrange these numbers. So instead of first multiplying 4 times 2, the associative property tells me I can multiply 2 times 3. 2 times 3 equals 6, and 4 times 6 equals 24. In both of these answers, I have 24 each time. We're going to be using the associative property by multiplying fractions in today's video. But before we do that, I want us to focus on something we can all sort of understand or relate to. We all know what a car looks like. I want to multiply 4 times 2 cars. In other words, or in another way of showing it, I have 4 times 2 cars. Or 4 copies of 2 cars. We all know what a copy is. It's when we make a duplicate of something else. So that means that I'm going to be duplicating these 2 cars 4 times. There's 1 copy. There's 2 copies. There's 3 copies. And there's 4 copies. How many cars do I have all together? Remember, I made 4 copies of 2 cars. How many cars is that? Awesome job, it's 8 cars. We already know that. Simple, easy peasy. Now let's relate this to a fraction. What if instead of cars, I have 3/5? So I have 4 times 3/5, or 4 copies of 3/5. You see where I'm going here? 3/5 I know is just 1/5 plus 1/5 plus 1/5. So this would be my tape diagram that represents 3/5. But it only represents 1 copy of 3/5. How many more copies do I need to draw to have 4 whole copies of 3/5? You're right, I need to draw 3 more copies of 3/5. So here are my 4 copies, 1, 2, 3, 4. And all I'm going to do is just decompose my whole to represent 3/5 4 times, because I need 4 copies of 3/5. So there's my second copy. There's my third copy. And there's my 4th copy. So now I have 4 copies of 3/5. What do you think we're going to do next to figure out the product? If you said add all of my fifths together, you are absolutely correct. Now, you guys, I'm not going to waste time by focusing on my denominators, because my denominators are all 5. So that means my whole is 5. All I'm doing now is just adding my numerator. So 1 plus 1 plus 1 is 3. 3 plus 1 plus 1 plus 1 is 6. 6 plus 1 plus 1 plus 1 is 9. 9 plus 1 plus 1 plus 1 is 12. So 4 copies of 3/5, or 4 times 3/5, equals 12/5. Am I done? Nope, if you said I need to use a number bond to pull out holes, you are correct. What is the biggest hole that I can pull out of 12/5? Awesome job. I can pull out 10/5, which equals what? Good. 2 holes. What do I have left? Good. 2/5. So 12/5 is the same thing as just saying 2 and 2/5. Let's do another problem. In this problem, we're going to be using the tape diagram strategy and the associative property strategy to solve. So in this problem, I have 5 times 3/4. How many copies of 3/4 do I have? Awesome job! I have 5 copies of 3/4. Now that I know how many copies I have, it's time for me to draw my tape diagrams. Remember, I have 3/4, so that means I'm going to be decomposing this hole into 1/4 plus 1/4 plus 1/4. This is 1 copy of 3/4. How many more copies of 3/4 do I need to draw? That's right, I need to draw 4 more copies. One more. Now you guys, I have 1, 2, 3, 4, 5 copies of 3/4. What am I going to do next? If you said add them together, you're reading my mind. I have to add them together. We know my denominator is 4, my whole is 4, so I'm going to keep the 4 at the bottom, and now I'm just going to add my numerators. 1 plus 1 plus 1 is 3. 3 plus 1 plus 1 plus 1, 6. 6 plus 1 plus 1 plus 1, 9. 9 plus 1 plus 1 plus 1, 12. 12 plus 1 plus 1 plus 1, 15. So I have 15/4. Or, if I decompose this, I can pull out 12/4, which would leave me with 3/4. I already know 12/4 is equivalent to 3 holes. So 15/4 equals 3 holes and 3/4. So 5 times 3/4 equals 3 and 3/4. What if I want to use the associative property to solve the same problem? So I want us to look at our original problem. I'm trying to solve for 5 times 3/4. In order for me to use the associative property, one thing that's very important that I do is I need to write 5 times 3/4 in unit form. So that would look something like this. 5 times 3/4. Thumbs up if you're still with me. Now, the associative property says I can multiply any one of these numbers. And yes, fourths is a number as well. It represents my denominator. But what two numbers makes the most sense for us to multiply together? If you said 5 times 3, I agree. So let's multiply 5 times 3. But I still have fourths. Remember, fourths represents a fraction. It represents the denominator. So that means that on the bottom of 5 times 3, I'm still going to have 4 because fourths represents my denominator. 5 times 3 equals 15. And now we're just going to simply bring our denominator over. 15 fourths. Didn't we get that same answer when we used our tape diagram? We sure did. And we already know that if we decompose 15 fourths, we have 3 and 3/4. Thank you guys so much for watching this video. Thumbs up if you learned something new, and also comment in the chat below, the comments below, which one is your favorite strategy, the associative property or the tape diagram strategy. I'll see you guys in our next video.